Good evening guys and welcome back to PC1. In the last AMA we gave you an overview of many of the first off components that we need to build for the very first GT50 engine. As April now is upon us, we're coming to the end of the manufacturing phase of all of the prototype parts and we're getting ready to assemble that very first prototype engine. Let's have a walk around the machine shop and the factory and I'll show you all of the last few components that are being made for that very first engine. So having watched us for months and months develop all of the processes that we need to cast high integrity super alloy components for GT50, we've now finished casting all of the cast components that go into that first GT50 engine. We've got enough castings to make 3 engines, including a number of key variants of each of the components that will allow us to tune and optimize the engine experimentally on the test rig. We're now reliably casting high pressure turbine blades, we're now casting low pressure turbine blades for the power turbine and all of the structural components that we need for the core of that engine. Let's go and have a look at some of the incredible quality stuff that's coming out of the casting shop thanks to Mark and his team. So what you can see here is no fewer than 7 high pressure nozzle guide vanes. So you only need 1 of these for an engine. And what we've got here is the nominal geometry. And as you can see, we're now casting these absolutely perfectly. So these are coming out with the trailing edges intact. They're coming out with the right surface finish. We're getting the throat area nice and accurately. All the shrinkage has been accommodated for. And so all that remains to get these engine ready is they're off to heat treatment as soon as we've finished shooting this video. And then when they come back, they're on for the machining operations to get the faces cleaned up, ready to connect to the engine, and then the EDM operations to put the cooling slots in. Now, you might well ask why we've got 7 of them. And the reason for that is twofold. Firstly, we've made spares because we fully expect to damage the engine while we're doing the testing, in part while we're learning how to operate it, and in part when we're pushing it to its limits to understand what it's capable of doing. And so we've got spare parts for pretty much every part of the engine that we've made, so we can quickly strip and repair or strip and replace any components that we've damaged during testing. One of the other things that we need to do is the amount of flow that gets passed from the compressor down into the turbine is actually controlled by the gap between these turbine blades. That's the restricting orifice in the engine, and it's very difficult a priori to know exactly what that area needs to be, because it's a function of the compressor and the turbine efficiency, which you don't know until you've tested it. So the way that we get around that is we've got the nominal geometry, which is the design intent, and that assumes all the components do exactly what they should. But we've also got a cutback geometry, which is this one here, where we've essentially cut these blades back a little bit and opened up that throat area. And what that will allow us to do, it'll allow us to pass a little bit more mass flow. It keeps the compressor further away from its surge line, and it keeps the temperatures cooler in the engine while we build up experience operating it, so we don't damage anything on the early runs. So once we've got the engine running nicely, we go to the tighter restricting orifice. That will get the engine running at slightly higher pressure ratios, slightly warmer, and hit all the fuel consumption and power targets. So the way that the testing will roll out is 1 step at a time, and minimizing and managing the risk as best we can. We're bound to break stuff, but we do that in a controlled manner, knowing that we've got the spare parts to replace afterwards. So as soon as these nozzle guide vanes come back from heat treatment, where they're off right now, the next operation is to get them onto the machine and machine off all of the mating faces that connect it to the engine and the ceiling really accurately. And then once we've done that, we can then go in with the EDM operations that we've showed you previously to cut in the hollow passages that allow us to cool the center of the blades. And then the final op is to go in and to use this large EDM tool here to go in and sink the detail on the back face of the nozzle guide vane that we use to capture the metallic sealing rings that hold this in a gas-tight seal to make sure that all the hot gases go through the controlled passages and don't leak around the outside. That's the final op to get these ready to install in the prototype engine. So you've watched us develop the annular combustor for GT50 over the last couple of years really, and now all of that hard work is starting to pay off. So what we've got here behind me is all of the rings that make up the annular combustor for 3 full combustors. And the reason we've made 3 again is so that we've got spares, but also importantly so that as we develop the testing, if we need to tweak the primary and the secondary dilution holes or the impingement cooling holes, the areas or the flow proportions of those, we can do that on the fly without having to wait to make a whole one. So if I just show you what we've got over here, these are all of the individual rings that go into making the annular combustor, all now essentially waiting just to be assembled and welded together, ready for installation into the engine. So we've got the inner rings, roll formed, sized, all drilled with the correct holes in them. And you've got all of these, some ones that look fairly similar, but each and every one of these is slightly different. They've all got a really carefully controlled profile. They've all been sized really accurately so that they go together. Then we've got the outer rings and the joining rings that include the sliding joints so that the combustor can breathe as it starts to heat up and hit the sort of crazy metal temperatures that we see. Then we've got the larger outer rings for the center portions. Another one of those there. And then we've also got some of the forward flat portions as well that are more plate-like. They've been pressed. And then we've also got some deeper drawn sections. So these are some of the complex pressed forms that we've had to develop, again using a combination of simulation and experimental development methods to be able to make these forms accurately. And then finally, we've also then got the main head of the combustor. So this has got the impingement cooling holes on the back, the plates that capture the sliding washers so that the thing can breathe as it gets hot. Then we've got the heat shield inside, all again slotted so that it can breathe as the thing gets warm. So that's waiting to go onto the back of the first combustor. And then we've got a bunch of deep drawn sections as well. There's a couple of them here, look. These are the internal bends that gooseneck round into the mouth of the nozzle guide vane. And then we've got the inner long deep drawn sections that we've had to produce as well. And all of these components have to then be joined together to form a completed prototype GT50 annular combustor. So 3 of those now waiting just to be welded and installed in the engine. So another key component that will be over the line in the next week or so is the vane diffuser. So we showed you this component during the AMA with the nozzle guide vane or the engine core mounting brackets here, the straightening vanes coming out the back, and then the vane diffusion passages that the compressor pumps air through. This is out being brazed at the moment. That's being done right now. So over the course of the next few days, we should be getting the results of those trials and getting the very first one of these back. And providing it hasn't warped all over the place, that'll be the one that goes into engine number 1. So here we have the first full 3 engine sets of conforming GT50 high pressure turbine blades. So each and every one of these has been cast right here out of the correct super alloys at PC1, and then it's had its machining ops, it's had its grinding ops, and then the little EDM ops for the wire locking features, all of the necessary NDT to be able to run in the engine. And these blades are now sat here waiting to be assembled into the first engine. So we've now completed 3 engines worth of high pressure turbine blades for the gas generator. The next job is the low pressure turbine blades for the power turbine. So we've got again 3 engines worth of cast blades, all complete, all back from heat treatment. They're waiting for some machining ops here, and then their final grinding ops for the fir trees, and then those ones will be ready too. So one of the important aspects of the work that the production team are doing at the moment is, as we make these first prototype parts, everywhere that it becomes clear that there's a design feature or a sort of aspect of the part that makes it difficult or expensive to make, we're taking the opportunity to improve it. So this is the intermediate stub shaft that was on the rotor that we balanced. And what you can see is in the shaft, we've got these slotted holes. And these are there to manage the swirl going from the stationary part of the engine into the rotating shaft as part of the secondary air system. Now the problem with these slots is they were essentially because of the size of tool that you need to use to cut them out, they were taking hours to machine, really starting to drive the cost of manufacturing that part. So during the manufacturing process, we've adapted the part and we've adapted the secondary air system to, instead of using slotted holes, using a greater number of round holes that are much quicker to manufacture because we can simply drill them. So that's been captured as part of the manufacturing feedback loop, and the parts that will go onto the test engine are these that have got the as production design intent already built into them. And what you can see behind me on the lathe over here is that Mick's building the latest generation of shaft components for the 3 test engines. So they're going through at the moment capturing these kinds of details that have been picked up by production or tweaks that have been picked up by metrology to make sure these parts are as representative of what we'll produce in volume as they possibly can be. And then another key area that we've been working on as well is, of course, the Hill high-speed bearings. So we have to make all of our own bearings for the GT50 engine in particular. So the guys at the moment are working on the split bearings that live in the heart of the engine. These are the bearings that run faster than any other bearing in the aircraft. They're the most difficult ones to design. They have the tightest tolerances. They're the most difficult ones to make. And we're just finishing off here the cages and then the split elements of those bearings. All of the rolling elements are already here. So as soon as we've got these done, we can assemble them and they're ready to go into the engine. So I mentioned in the AMA that we've got a number of 3D printed cases being made at the moment, and these are for the instrumented prototype version of the engine. So one of those is an updated version of the combustor case. This takes the latest fuel injection system, it takes the latest combustion liner, but importantly, it's got all the bosses on it for the different types of instrumentation we need to closely monitor that first engine during test. So that's on its way to us at the moment. We've also got 2 additional big casings. We've got the interduct that passes the flow out of the power gas generator and into the power turbine. That's due in over the next week or so. And then we've also got 2 aluminium casings at the front of the engine, and this forms the smooth bell mouth that feeds the air into the compressor and houses the accessory gearbox that drives your oil pump, your fuel pump and the various other bits and bobs. Those are being printed at the moment and they'll be with us shortly as well. So in parallel with bringing the last bits of manufacturing over the line and then dealing with the first build of the engine, running a jet engine for the first time, certainly in a partial build state as well as a full built state, is a fairly big deal. And so in parallel with the build of the engine, we're now on with the build of the test environment and the test equipment to be able to physically run the engine. There's a number of aspects that we need to consider there. We need to consider the noise. When we first run the gas generator, that's essentially a turbojet without a power turbine on it. It will be incredibly noisy. So we've had to develop a whole acoustic enclosure and an exhaust treatment system to be able to get the noise out of that jet plume down to an acceptable level where we can do the matching work on the compressor and the turbine and run that for long enough to prove out the core of the engine. That gets simpler when we then put the power turbine on it, because the power turbine absorbs a lot of that energy, but it means that the test facility needs to be flexible, both in terms of the acoustics, in terms of the instrumentation, in terms of the way that we mount the engine on the stand, and then in terms of how we operate the engine under these various conditions. So that work's going on in parallel with the work to build the engine itself, and the fit out of the internals of this start in earnest next week. You can also see just behind me that we've got a 10,000 litre jet fuel tank here now, and that's fully operational and ready to feed the test cell so that we're able to do the slightly longer runs that we'll need to do for the endurance aspects of the testing program once we've got the engine set up and configured properly. So all of this side of it's coming together as well. And then ahead of the main engine testing, we've been doing much more combustion testing, which I'll go and show you now. So in addition to the whole engine testing, we've also significantly now upgraded the combustion test facility. This now allows us to use much higher pressure fuel systems in line with the actual nozzles that we're using in the test engine. It allows us to calibrate essentially all of the combustion parameters that we need to get that first ignition running smoothly in the test engine. We need to prove that out in a fairly benign environment to avoid well, to minimize the risk of doing any serious damage to the prototype engine in the very early stages of getting it lit and getting it running up to stable ground idle. So a lot of that test work is going on here at the moment. This is optimizing the hole pattern in the combustion liner, optimizing the nozzle sizing, the fuel injection pressures, the swirler geometry and flow numbers, and the various other things that we have to tune and play with to get combustion working nice and robustly and stably within the GT50 engine. Much of that can be done here. Those parameters are then set into the control system for the first GT50 runs. So until the GT50 engine is running on the test bench and doing all of its endurance testing, we're going to keep the focus of the AMAs on the engine so that everybody understands that's our top priority. But of course, the helicopter development has been going on in parallel with this in the background. So I'll just give you a couple of snippets of some of the juicy bits of what we've been working on, just to break up the tedium of the technical details. So the last couple of AMAs, we featured some updates on the crash-worthy crew seats, which again is entirely developed by us. We've been through a range of iterations on the tooling approaches to get the quality right, to get the consistency of the cure right, and to productionize the process as best we can so that the seats that we put through the crash testing are representative of what we want to use in production. So this is one of the latest carbon bucket tools. So this is a tool, it's not a part. So this is the back half of the carbon bucket tool. And what you can see just next to it on the bench here is a representative rear skin from one of the carbon buckets, along with some bagged up foams that have been pre-treated with film adhesive, ready to be wrapped in carbon, inserted into the rear skin and then mated with the front skin in the closed tool operation, ready for curing. So we've got this process working pretty well at the moment. It's technically okay. We've got a little bit of work to do in terms of making that productionized and hitting the cost targets that we want for the seat, but that's working really nicely. Now, aside from the technical side of the seat, you've watched us over the last 18 months or so really, following some feedback from the seats in the helicopters at Duxford, do an awful lot of work on the comfort of crew seats. Everybody understands that helicopter crew seats are traditionally instruments of torture, and we wanted to make sure that we put that right. So we went right back to basics. You saw us do a load of ergonomic trials where we could vary the seat angle, the back angle, tune the lumbar support shape and position, and then tune the density and the thickness of the foam that we wanted in different positions to make sure the seat was anatomically correct. Once we'd done that, the next stage was to go to the aerospace carbon loaded foams that meet all the flame retardancy and toxicity requirements, and then get those machines prototyped. We machined all of those here in the right materials, got the stiffnesses right, and then did the trials of including the foam and the bonded leather on the foam in a form that we could easily trim the production seats in, so that process worked really well. The next thing that we did was do a load of development on the composite system as a whole. So the seat bucket, and then the aluminium legs, the energy absorbers, everything that goes into making the seat work as a system. That was completed about 6 to 9 months ago now, and we've been prototyping all of that stuff studiously in the background. The two things that I wanted to show you today. This is actually a rigid seat mannequin for developing the trim strategy. We completed this about 3 months ago. This was a very simple version of the seat cover that's going to go over the seat, just to make sure that we could get to the sort of automotive levels of quality that we want in the cabin seat, and to get the final values for how much the as trimmed leather and foam combo add to the seat weight. And then literally about an hour ago, this arrived for the very first time, and this is the very first carbon bucket. So this is the first HX50 carbon seat bucket that we've made here, that's got the very first prototype foams that are anatomically correct, comfortable, and have got all the salvage groove details in there to make sure that we can trim it properly and it looks right. And then this is the current specification of one of the colours of leather that we're trimming the seats in. So we're not entirely happy with the upper cushion yet in terms of its aesthetic. We've still got a little way to go on that, but in terms of the carbon, the crashworthiness, the trim strategy, everything that goes into making this seat, it's done. this works really nicely now. So we're in the process of just doing a little bit of tuning on just the foam upper to restore some of the looks of this back part of it. And then we've got 12 of those waiting to be manufactured so that we can get them onto structural test and then ultimately crash testing. If you peer behind here, what we've also got is the very first metallic seat leg. So this one is machined from solid out of high performance aerospace alloy. In practice, we'll be casting these, investment casting them in a very high performance investment casting aluminium. And the reason for that is it gives us all of the benefits of the high performance and all of the performance of the high grade aluminiums, but we can manufacture them much more quickly and they spend a lot less time on the CNC machines. So the seats are suspended on 2 of these. These rails move against the floor and they pick up the rollers and also the energy absorbers and connect the seat back down to earth just as you need to meet all the crash cases. So we've got the seat rails going through, the energy absorbers going through, and the various paraphernalia for seat adjustment going through while we finish off the laminating of the test seat bucket. So really pleased with how that's going. Another exciting area of development has been the development of HX50's composite main rotor blades. In parallel with the engine development, the composites team have been developing all of the processes that we need to design, build, quality control and then qualify our main and tail rotor blades. At the end of the last AMA, I think I left you with blade 6 just starting to be laminated. Since then, they've completed the laminating, they've cured the blade, they've fetched it out of the tool, done all of the geometric inspections and done the cut-up inspections to have a look at the key sections and also to take a couple of key 1 meter or so length sections out that we can then use for structural testing to again measure the stiffness, but importantly this time look at the strength and the as molded properties of the composite material that we've created with the blade molding process. In addition to that, we've also done some different cut-up inspections this time where we've cut the blade longitudinally, allowing us to see the integrity of the carbon laminate in the difficult thick sections near the root end and how they then go down to the thinner sections that are found in the D-spar and the aerofoil lifting sections at the intermediate spans of the blade. So all of this is looking really, really good. These blades are already coming out of the tool very consistently. We're consistently producing good quality consolidated laminate. There's a bunch more of inspections to be done on this to check for any very small porosity and any other defects that might be in there. And then importantly, the next stage of development that the guys will be doing is making sure that we've qualified and developed all of the non-destructive testing processes that we need to be able to qualify these blades in production in high volumes. Another area that we've been developing extensively over the last 6 months or so has been the climate control system and the ventilation and heating system for HX50. HX50 is fairly unique amongst light helicopters in that it's got an automotive style climate control system. In order to validate the performance of both the air conditioning elements of that, the heating elements of that and the pure ventilation elements, we're using the old Fuselage 4 as a test bed for the full first version of the HX50 climate control system. So at the moment we're fitting out this early fuselage prototype with some floor structures, all of its doors and enclosures, and then we'll be mounting the evaporator, the condenser, all of the air handling equipment and a bunch of instrumentation, and this is then going off to the Myra climate chamber to be able to validate that the climate control system that we've sized and developed is adequate for the whole range of operating conditions that HX50 will see in service. So that work's going on now so that we don't bury this kit in the Gen 2 fuselage in a deeply integrated way without knowing that it works properly first. So the complex task of building over 250 complex gas turbine components for the very first time is now almost complete. We have the last handful of straggler components to get through the door and finished so that we can commence the build of the very first GT50 prototype. That's going to go ahead in May as planned, and then we should be running the engine within the month as we'd outlined. Progress from across the HX50 program is also at full steam, and we'll be reporting much more of this once we've got the GT50 running on the bench. Thanks for your attention, and we'll speak to you again soon.